Welcome to a new video. In this video, we will continue to talk about logarithms. In logarithmic inequalities, there is an important point about base. We have 4 rules about the inequalities in logarithmic functions, and all of them are related to the value of the base. Suppose that we have such a logarithmic function. In this function, a represents the base value. So if you look at number 1, it says if the base value is greater than 1, and if there is such an expression like this, what we can see here, okay, there are 2 logarithmic functions, logarithm of b in base a and logarithm of c in base a. As you can see, the bases are same, and we are just comparing the numbers b and c. If a, which is base, is greater than 1, then definitely we can conclude that c is greater than b. We have an example here. For example, if you look at the first one, okay, suppose that we have such an inequality where it says logarithm of x in base 2 is greater than logarithm of 3 in base 2. So as we can see, the base is 2, which is greater than 1. And in this case, x has to be greater than 3, guys. And if you look at number 2, okay, in number 2, our features tells us that, again, suppose that the base is greater than 1. Here, if you look at this expression, okay, the second one, if c is greater than logarithm of b in base a, and if this is the case, we can conclude that a to the power of c is greater than b. So what this symbol tells us is, okay, we can conclude the right part, which is this part. And also the reverse order is also true. So this symbol means if and only if. So we can say that logarithm of b in base a, which is less than c, if and only if a to the power of c is greater than b. We have an example also about the rule number 2 in example 2 here. Suppose that logarithm of x in base 2 is less than 3, and if this is the case, I'll just bring that 2 to the right, okay? So it's going to be 2 to the power of 3, and the symbol stays as it is, and on the left, x stays as it is. So we see that from here, x is less than 8, which is 2 to the power of 3. And now if you look at feature number 3, if a is less than 1, we all know that the base has to be a positive real number, so it has to be greater than 0. We all know this. So if a is between 1 and 0, in this case, once we have such 2 logarithms, okay, where logarithm of b in base a less than logarithm of c in base a, in this case, b has to be greater than c, unlike number 1, okay? So for number 3, we have an example here. As we can see, our base is less than 1, which is greater than 0. And here we have the same thing. The bases should be the same, guys. So if this is the case, and then we can conclude that 3 has to be greater than x. And as a final rule, again, we have the base, which is between 0 and 1. And if there is such an expression, logarithm of b in base a, which is less than c, and then we can conclude that this is true if and only if b is greater than a to the power of c. And the example for number 4 that is here, which tells us that logarithm of x in base 1 over 2 is less than 3 if and only if x is greater than 1 divided by 2 to the power of 3. And this topic is a little bit complicated, guys, so I recommend you to make more practices, and we will solve 3 questions related to these features to master the topic. Let's continue with the first question. In this question, we are asked to find the interval of x, or the values of x. As we see here, the first thing you need to realize in such questions is, guys, whether or not the base is greater than 1. So as we can see, it is 3, so it is greater than 1, which means that we need to apply the second rule here, okay? So just send this 3 to the right, okay? Pretend that there is an equal symbol instead of less than symbol, okay? If it was equal symbol here, then what we were doing in our previous examples was 3 was coming here, and that 2 was coming as a power to that 3, okay? And then that x minus 1 coming to the down as it is. So x minus 1 is here. And again, instead of equal sign, then I'm just bringing that less than symbol here. So everything is same, okay? Suppose that there is an equal symbol instead of less than symbol. So x minus 1 is going to be less than 3 to the power of 2 is 9, guys. So just leave x alone. Just send this 1 to the right side. Here it was negative 1, and now it's going to be a positive 1. So x is less than 9 plus 1. For the people who don't know how I did this 1 and send it to the other side, I recommend you to take a look at one of the previous videos about shortcuts in calculations. And in the next step, of course, we see that x is less than 10. How we can show it? Well, as a solution, x is an element of the interval. X has to be less than 10, guys. So 10 is here. And then there is a must, okay, in order to make this logarithm valid, x minus 1 has to be greater than 0, right? So just send this to the other side. So x is going to be greater than 1. In this case, 1 is going to come over here. So just combine this and then combine this. And then we can conclude that x is an element of this interval. And the interval is 1 and 10, guys. So in other words, x is less than 10 and it is greater than 1, and that is the solution, guys. And let's continue with the next question. Okay, in this question, as I said before, the first thing you need to realize is whether or not the value of the base is greater than 1. And as you can see here, in this case, it is less than 1. So we will apply the fourth feature from the features above. So what we were doing was just send this 1 divided by 5 to the right. Okay, 1 divided by 5. And then this negative 2 was coming as a power to that number, negative 2. And then x plus 1 is coming down as it is. And then here, because the value of the base is less than 1, so just switch this less than side, okay? So it's going to be greater than, guys. And 1 divided by 5 to the power of negative 2 is what? This number can be written as 1 divided by 5 to the power of negative 1 to the power of 2, guys. Once you take the negative first power of 1 divided by 5, then it's going to be 5. And once you take the square of this, then this is going to be 25, guys. So the right side is 25. X plus 1 is greater than 25. Just send this one to the right. So it's going to be x is greater than 25 and minus 1. If this is the case, x is greater than 24, guys. And which value of x makes this number 0? So which is negative 1, guys. So x has to be greater than negative 1, and it is less than 24. So we can conclude that x is greater than negative 1 and less than 24. As an interval, we can write it as negative 1 and 25. I mean, it should be 24, guys, here. 24. And that is the solution of x in this question. And let's continue with the next question. In this last question, again, we are asked to find the value of x. But we need to take into account that x has to be a positive integer. So how we can find the x values? Well, firstly, let's take a look at this inequality, okay? And then after finding the values for x, and then we will take a look at this inequality as a second option. If logarithm of x in base 2 is less than 3, just send this 2 to the right, and x is gonna come down as it is. So x is less than 2 to the power of 3, guys. And if this is the case, of course, x is less than 9. And once we take a look at the second option that we have here, just let me write it here. 1 is less than logarithm of x in base 2. And again, send this 2 to here, okay? So it's going to be 2 less than x. So we see that x has to be greater than 2 as well. If you combine those two conditions, this one and this one, and then we see that x is less than 9, and that is at the same time greater than 2. If you have any question, you can just write them down below in the comment section. Thank you for watching, and hopefully see you in the upcoming videos.